Okay, it's 7 on the dot. We can start now. So, how's everyone doing today? Good? Tired? I get you. Don't worry, the week's almost over. So, I was looking at assignments, and it looks like week 4 material is going to be due exactly a week from now. So, we're going to do the same thing we've been doing before and just do the sections. And then next class meeting, we can do the labs. Now, nice thing is that in this week, there's not that many sections. Okay. So let's go right to it. So we're gonna start with string comparisons. So string comparison equality. Two strings are commonly compared for equality. Equal strings have the same number of characters, and each corresponding character is identical. So let's do this participation activity. Which strings are equal? I'll zoom in. I'll just point out the question. You guys tell me if they're equal or unequal. So this one?
Equal.
Yep. This one?
Unequal.
Yep, because apple is not the same as apples. And then this one?
Equal.
Equal.
What about this one?
Unequal.
Unequal.
Yeah, unequal because one's capitalized, right? Awesome. So string equality example censoring. So the user enters a word, and if the word is Voldemort with a capital V, it'll output he who must not be named. But if they put Voldemort with a lowercase v, this is not the same as uppercase v, so it'll output Voldemort, right? All right, next participation activity, comparing strings for equality. To what does each expression evaluate? Assume string 1 is apples with a capital A, and string 2 is apples with a lowercase a. So string 1, and as you already know, or at least I hope you know, the double equal sign is the comparison operator. The single equal sign is the assignment operator. So it's checking to see if these are the same, right? So is string 1 equal to apples?
Yes.
Yep. Is string 1 equal to string 2?
False.
Nope. That's right. And then string 2, obviously it's false, right?
That'd be true.
Oh, it says does not equals. There we go. Yeah, it would be true because apples is not equal to oranges. Okay. Okay. Next one. Here's a participation activity. So strings are sometimes compared relationally, less than, greater than, when sorting words alphabetically. A common comparison begins at index 0 and compares each character until the evaluation results in a false, or the end of the string is reached. A is 65, B is 66, while lowercase a is 97, B is 98, and so on. So is anyone here familiar with ASCII? So
I've heard of it, but not like know what it exactly is.
Okay, well, in ASCII, every character on the keyboard is associated with a number. So as I was saying here in the slide books, capital A is 65, capital B is 66, and that corresponds here. While lowercase a is 97, lowercase b is 98, and so on. That's what it's referring to. So when we compare strings, it'll check each character 1.1 until either a character is different or we reach the end of the string. Now, in this example, uppercase J and uppercase A are not the same. So when it compares these two strings, it'll return false, right? Okay. Next one, indicate the result of comparing the first string and the second string. Apples and oranges. I think you would need to know, you would need to see an ASCII chart in order to do this, wouldn't you? So in the previous example, we say that student name is greater than teacher name because the ASCII number for uppercase J, 74, is greater than the ASCII number for uppercase A, which is 65. See? So indicate the result of comparing the first string and the second string. Well, uppercase A is 65 in ASCII, and then uppercase O is 79 in ASCII. So which one's greater? Oranges would be greater, right? Because 79 is greater than 65. Oh, yeah. Because I'm comparing the first string to the second string, right? And then for the next one, we have Mary with a lowercase m and then Mary with an uppercase M. Which one's greater and which one's less than?
It's greater than. Should be greater than.
Greater than, right. And what about this one? Well, I would think that because we're reaching the end of the string here, but this string reaches another character while this one has none, banana would be less than banana rama because we have a lack of value compared to whatever number lowercase r is, 114, right? Okay, next one. Write an expression that evaluates to true if my name is greater than your name. So I hope that everyone has seen all of the different relational operators in C++, right? We have greater than equals to, less than equals to. So what would I put in? What symbol would I put in here if I wanted to evaluate the true if my name is greater than your name? I mean, it's in,
the less than. I mean, yeah, the greater than. I think.
yeah, it's in the question, right?
Yeah, I don't know how to actually explain what the symbol is.
Yeah, it's the greater than symbol. And then write an expression that evaluates to true if author name 1 is less than or equal to author name 2. This one's easy as well. The answer is in the question, right? We're going to put less than or equal, right? It's not. Author name 1. Oh, I have to actually put the operands in there. My bad. I'll do that right now. Author name less than or equal to 1 less than or equal to author name 2. There we go. Okay, now here's a challenge activity. Write an if-else statement that prints goodbye if user string is quit. Otherwise, it prints hello. So this one's a pretty easy activity. I'm going to let you guys tell me what to write. Does anyone want to volunteer? Well, we'll start by writing an if statement. If, and inside the parentheses, we need a clause in there that can be interpreted as true or false. In this scenario, we need to see if user string is equal to quit with a capital Q. So if I'm going to say user string is equal to quit, and I'm using the doubles equal sign here, and then quit is going to be in parentheses, right? So if this is true, we're going to output what?
Goodbye.
Yeah, goodbye. So I'm going to say cout goodbye. And if it's not quit, we're going to print hello. So how am I going to do this? I'm going to have to put an else statement here, right? Open, close, squiggly brackets like that. And then, what should I type in here?
Cout hello.
Yep. Cout
And then end L.
hello. Does it want us to end with a new? Yeah, it does. Thanks for catching that. Line. And line. So what's going to happen here is that when it sees this if statement, it's going to check this condition. If the condition evaluates to be true, and in this case, the condition is if user string is equal to quit, we will execute these lines of code, right? But if it's not true, this will be ignored, and we will execute these lines of code. So if we ran it, yep, that's exactly how it should look. Okay. So here's the next challenge activity. So it says, print the two strings, first string and second string, in alphabetical order. Assume the strings are lowercase and end with new line. So, oh, Daniel asks, can you go back up? Okay. Okay, Daniel, did you already get this? Are you good?
It's saying, I'm trying to do mine, but it's saying that the white space isn't working.
Huh? I'm sorry?
That the output for goodbye isn't working.
Okay, for your if statement, did you put double equals instead of single equals? Because people make that mistake a lot.
Yeah.
You did?
Yeah.
Is your goodbye a capital G?
Yeah.
Okay. I'm gonna stop my share and then we can look.
Wait, did you put end L?
Yeah, I did.
Okay, let me try that first.
Oh yeah, because it needs you to end with a new line.
Yeah, there we go.
There you go.
I just didn't see the end L.
Okay. Great. So Daniel, are you good? Can I scroll down again? Okay. Well, I guess we'll move on to it. Okay, great. So this one says, print the two strings, first string and second string in alphabetical order. Assume the strings are lowercase and end with new line. Now, this one's actually, this challenge activity builds off of what we learned here, right? It's going to be very similar to this. So the way I think we're going to type this is we're going to have another if statement saying if first string is less than second string, we'll see out first string, then second string. But if that's not true, we'll see out second string, then first string. Do you know what I'm saying? So does anyone want to tell me what to type here? Does anyone have an idea? I'm going to say if, right? And inside the parentheses, I need a true false, a statement that can be interpreted as true or false. In this case, I'm going to check if first string is less than second string, right? Like that. Ken Matharu. So if everyone can look at this the chat right now, Ken just typed in some code and looking at it, it looks like his code would work. But I wonder if it wants us to put an NL between first string and second string. Does it want us to do that? It doesn't say. But we're going to do it your way, Ken. So we're going to say C out first string, and then space, and then second string, and line, like that. But now we need to account for the scenario where first string is not less than second string. In that situation, we need to do it the other way. So I'm going to put an else here. Open, close brackets. And instead of saying first string, second string, I'm going to say second string, first string, right? Do you feel like this will work? Yeah, like Ken typed in the chat. So if we ran this, yep, it works. So who else needs to see this? I'm gonna.
I do.
Okay, great. Good job, Mr. Matharu. Arturo Perez says, I put if first string equals capes and second string equals rabbits and still worked. Oh yeah, but what if that's for the sample output, right? What if for one of the other tests you get clearly and clear and wand and wand like that? This needs to, it's got to be a general solution, right? So does everybody have this already? Am I good to move on to the next section? Okay, great. Okay, so this one's about string access operations. So string character indices. A string is a sequence of characters in memory. Each string character has a position called an index, starting with 0, if not 1. So, so for the string Mary here, we have the characters M, A, R, and Y being saved into memory, right? Now, the indices are always start at 0. So we call M the 0th element or the 0th character of the string. A is the first element of the string. R is the second and Y is the third. Now, the reason why we started our counting at 0 and not 1 is because if you look inside the RAM of your computer, you have a sequence of memory addresses, right? The label of the first memory address is always 0. So we always start our count at 0 so that the index lines up with the address of the memory address. I hope that makes sense. Anyways, we can do this participation activity now. So since you know that in computer science, we always start our count at 0. For the string light with a capital L, what is L's index? Okay, let's start with this. Who here thinks that the index for L is 0? And say it in the chat. Okay. Who here thinks it should be 1? Okay. Well, I see more zeros than 1, so let's try 0. Yeah. It's 0 because the first index is always 0, right? So for the next one, light, what is I's index? Go ahead and type in the chat what you think it is. 1? You're right. What about T's? Yep, it'd be 4. You guys are sharp. And then for the string oh my, with O and then a space and then my, but this is all one string. Well, what character is an index 2? Space, exactly. For the string you wish, what character is that index 4? Yep, W. For the string you wish, what character is that index 9? Yeah, there's none because we don't see a 9th character because the indices end at 8, so there's no 9th index. But that's good. So here's another sample program that says word scramble. Okay. So it says, it looks like the user is prompted to enter a word, a 5-letter word, and then it scrambles it by putting the, it outputs the character at the 3rd index, then the character at the first index, then the fourth, then the 0th, then the second. Now, if you look closely at this program, this program makes use of the .at function, which is a member of the string library, right? So what the at function does is you take a string and then you put at and whatever indices it is, it will return a character that's at that exact indices. So if you entered water, it would put out EARWT. It would put out E first because E is the third index, and then A because A is the first index, then R because R is the fourth, then W because it's the 0th, then T because it's the second, right? So this is a good lesson. I like this because it's introducing you to the string library. So moving on, given string user string is run, indicate character X's value. So go ahead and tell me in the chat what you think X will be equal to if user string is equal to run exclamation point. You think it would be R? Yep, that's correct. What about this one, number 2? What would it be at 3? Yep, exclamation point. And then lastly, this one, user string at 4. Yeah, it would be an error because there is no character at indice 4. Right. All right, so here's another sample program. A character in a string can be assigned if user string is A, B, C, D, E, then user string dot at 3 equals, wait a second. Hold on. Okay, so it looks like what this sample program is doing is that the user word is caterpillar, right? Which has 10, which has indices from 0 to 10. Now, it wants us to enter an index from 0 to 10. And whatever character is at that index, it will get replaced with an asterisk like this. So if we enter 0, it'll output caterpillar, but the C is replaced with an asterisk. If we put 3, this character will get replaced with an asterisk. And then if we put 10, this character is replaced by an asterisk. So with that in mind, let's do this activity. Given string first name is Ron, what is first name after we say this? If we said first name at the first index, we're going to change that to who here thinks it'll be the first one? Or who thinks it's the second one? It would be this one, right? Yeah, because the first character pertains to the O in Ron, right? What about question number 2? What would happen if we changed the third index to a capital and an exclamation point? Error, right? Because Ron only has indices 0, 1, and 2, right? So if you tried to change the third one, it's going to look for an item that doesn't exist, and that's going to throw an error. What about this one? Yep. This one's an error as well. Does anyone know why it's an error? well, the reason why it's an error is because this is a car, and we have to set it equal to a car. Quotes x quote is a string, and a string is not a car, right? Okay. That's actually a good exercise. So, here's another sample program. So this one says, working with the end of a string. Determining the last character in a string is often useful. If a string's length is known, the last character is at index length -1. Okay, so this lesson is teaching you all about the size function of the string library, right? In the previous sections, we learned about the at function of the string library. This time we're learning about the size function. Okay. And apparently it's also teaching you the append function, which is actually one that I don't use too often, but it looks useful. So if we had string 1 equal to hey, and then we append exclamation point, exclamation point, exclamation point, this will turn S1 into hey with 3 exclamation points, right? So I'll be right back, guys. I need to check on something. Sorry about that. So in this participation activity, what is the index of the last letter in hey? The options are 2 and 3. Type in the chat what you think the answer is. If you think it's 2 or 3. Yeah. It's 2, right? Yeah, it'd be 2 because H is the 0th, E is the first, and Y is the second. Okay. And then what is the length of the string hey? Yeah, it would be 3. Correct. Now, last one. Is a string's length the same as string's last index? Well, obviously it's not, right? So we can cross this one off. So who thinks it'd be 1 greater or it'd be 1 less? Yeah, that's correct. It would be 1 greater because 0 is counted, right? Great. Now, here's another participation activity. User text is the string March 17th, 2034. What does user text.size return? Well, this would be very easy to figure out. All we need to do is count the number of characters that's in the string. So I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So I believe this will return 14, right? Yep. And then next, what is the index of the last character in user text? Type in the chat what you think it could be. 13? Yep. And then lastly, what character does user text.at user text size -1 return? What do we think that this will return? So if the user text.size was 14, 14 -1 would be 13. So this is the same as saying user text.at 13. what is the last? What is the character at the 13th index of this? 4, right? Very good. You guys are sharp. All right, next one. For each question, user string is initially done. The string.
Could you repeat what you said about number 3?
Which one? This one?
The one we just did, yeah.
Sure. So let me actually do it this way. So we want to know what user text.at user text.size -1 is. So the first thing it does is it evaluates what's in the parentheses. We already know that user text.size is equal to 14, right? And then 14 minus 1 is 13. So it's actually saying user text dot at 13. That's actually what it's saying, right? So we want to know what's the character at the 13th index of user text, right? So obviously it's going to be the last character, right? And the last character is 4. Does that make sense?
Yep. Thank you.
Great. Okay. So I'm going to go close this. All right. So this one says for each question user string is initially the string done, right? Indicate user string's value after the statement provided. Do not type quotes in your answer. So, okay. So if we have the string done and then we append exclamation point to it, what would the answer be? Type it in the chat. What do you think it'd be? Yep. Done with an exclamation point. Right? What about this one? What would it be if we appended done question mark, right? Okay. Now there's actually an error here that's easy to miss. If you look closely at number 2, you'll see that the question mark is surrounded by single quotes. See, we use single quotes to surround a character. We use double quotes to surround a string. In this situation, the append function has to always accept a string, or I believe that's what it says, right? Yeah, it appends a string. I can't append a character, right? So this would actually be an error, I think. Or actually, would it be unchanged since I can't put error? Or would I? Oh, if appropriate, type error. Error. There we go. What about this one? I zoomed in for you so that you can see. What do we think the answer to 3 might be? Yeah, done now with a space, because if you look closely, there's a space right here. So if we put done now. Yep. Okay. So number 4 says we're going to declare a variable called another string and set it equal to yet ... And then we're going to append user string with another string, right? So what do we think user string will be equal to now? Yeah. Done yet. Because there's no space here, right? Yep. And then lastly, What about this one? What do we think this will do? Now it's trying to throw you off because it's putting a function inside of a function. We're putting the dot size function inside of the dot at function. But putting functions inside of functions wouldn't screw anything up as long as the data types are matched, right? So what do we feel about this? I think it would be worthwhile to talk about this. Let me open paint.net. One moment, because I feel like this would be a good exercise. So it's worth talking about. So we have this, right? So user string.at. The at function needs to accept an integer value, right? So user string.size. Size returns an integer value. So that's perfectly fine, right? But we need to know the size of user string. And it looks like the size of user string done is going to be 4, right? 4. So this would actually become this, except we would get rid of all this. And then we would replace it with 4, right? So let me get. And then I'll just move this back over. So essentially, this would turn into this, right? Do we understand that? So because we're trying to change the 4th index to a t, this would actually throw an error because the highest index is 3, and we're trying to change the 4th one. So it's looking for something that doesn't exist, and that's going to be an error. Check. Okay. Now, I hope that makes sense. But now that you know that, what do we think 6 is going to be? So, as Ken Matheru says in the chat, for the last one, it'll work because size minus 1 is 3, and 3 is the last index. That's correct. So this would be changed to, we would change the E to a T, so it'd be don't. There we go. Perfect. All right, so here it talks about some common errors, right? So we have, actually, I'm going to go ahead and start this. Yeah, the username is cat, right? We're going to execute these lines. And we set W equal to C, X equal to A, and Y equal to T. But here in Z, we're setting it equal to something that's out of range. And if we go out of range, it would throw an error, right? Yeah. To answer your question, Mr. Matheru, yes. Our answer for 5 would be a out of range exception error. And that's why. Okay. So with that in mind, we can start looking at this. So user text is equal to Monday with a capital M. User text dot at 7 equals exclamation point. May write to another variable's location and cause bizarre program behavior. True or false? Yeah, true. Yeah, it'll crash. What about this? User text at the 7th index. Do we know what the square brackets do, or do I need to explain that? Well, the square brackets, they do the exact same thing that the at function does. So, yeah. So in case you were wondering, this is the way you would access a character in a string using C. But since we're using C++, it's better to use the at function, just so you know. And then lastly, what about number 3? Do user text.at, user text.size is Y. Is this true or false? Yeah, it would be false because the size would be 6, but the index for Y is 5. So it would be an out of range error. Exactly. Okay. All right. So this looks like the last challenge activity for this section. Assign the size of user input to string size. So, okay. So what we're trying to do in this program is it looks like we need the user to enter a string, and then we output the size of the string, right? So here's our starting code, right? Now, before I proceed any further, so we have one thing I noticed about this program is that it uses the Getline function. Do I need to explain what this function does, or have you already seen it? Should I go ahead and explain it anyways? Okay, so I'm going to take a moment to explain what the Getline function does. So I guess I'm going to open. Well, actually, I can just tell you instead of just show you. So the Getline function does the exact same thing that the cin function does, except it accounts for white space. Okay. If we just said something like cin chevron user input, we would take everything that the user types in as a string up to the point where we see white space, like a space, right? But because we want to include spaces in our user input, we would use the getLine function instead of the cin function. Does that make sense? Or do I need to demonstrate it? We're good? Okay, great. So this is a very easy challenge activity as well. The way I see it, I think we're only going to put one line of code. Does anybody have any suggestions? I can see in the chat that Ken Matharu has one. If everyone can look at the chat, does everyone agree with his code where he says strings equals user input size. And I believe that's all we have to do, right? So how many people here thinks that this will work? I think it'll work. Let's see. Yep, it works. So thank you, Mr. Matharu. So anyways, it looks like it's 7:50 now and we've reached time. So on your own time, we already did these two sections. On your own time, I would like you to do sections 4.3 and 4.8 on your own time. And then next Tuesday, we can start doing the labs.
Hey, Orange, I was thinking about, like, I said in the beginning of class, but I think you didn't get to see it, about that, I've tried to retype the chains lab and I still can't get it right.
Oh, okay. If you want, you can stay behind after everyone else leaves and we can look at it together.
Okay.
Okay.
Okay, thank you.
So does anyone else have anything else? If not, I'm going to end the meeting here, but I'm going to stick around so that I can help Miss Valerie Mora. But aside from that, if no one has any questions, you're free to leave. But thanks for coming and have a good weekend. Thank you too, Logan Ashbaugh. I'll just wait until everyone else goes and then we can. Thank you, Mr. Slayman Toki. Thank you, Mr. Aaron Massey. Okay, so once everyone else leaves except for Ms. Valerie Mora, I can start helping you out. Okay. Well, that's close enough. So, Miss Valerie Mora, do you want to share your screen and then we can look
Yes.
at it together?
Let me just have you enable it real quick.
Yeah, I have to give you permission real fast.
Yeah.
Alright. Okay. So go ahead and make your browser full screen so we can just like see everything.
Okay.
Yeah.
Okay, wow.
I don't know if you see it on your screen, but there's like a black window in the way. Oh, you moved it. So. Okay, let's see what we have. Okay, so the very first problem I see on line 15, in the clause user input, that should be exclamation point equals, and looks like you have exclamation point minus sign. That's the first issue.
Okay.
And the exclamation point and equals should be together.
Together?
Yeah,
Okay.
no spaces in between. Because that's the not equals to operator, right? Okay.
Right.
Let's see what else we got here. User input minus dollars. That looks good. Quarters. That looks good. Dimes. That looks good. Nickels. That looks good. And yeah. So that looks okay so far. So if dollars equals 1, we'll output $1. Else if it's greater than, we'll put dollars. That looks good. Go ahead and stop scrolling for a second. Let me look at these other ones. Hoarders looks fine. Okay, on line 52, this isn't an error, but you should say diamonds instead of dimes. There you go.
Okay.
Okay. And then again on line 76, you should say pennies instead of penny. No, on line 76. Line 72 was okay. Was already all right. Yeah, and make sure you capitalize it. And make sure. Oh, I actually know.
I think it. Sorry.
No, go ahead.
No, I think it might be because I was having trouble doing the bracket line that leads up to here.
Yeah. So basically what we did was that by putting the bracket there and then the bracket on the bottom, all of that is one
Right.
condition. If you want, you could make it look neater. If you highlighted everything from line 18 to line 70 something. Go ahead and scroll down. Yeah. Yeah, scroll down some more. Everything up to line 77.
Okay.
If you did that and press tab, everything will scooch over. There you go. So it looks a little neater now, right?
Oh. Okay, now I can see the tab.
Yeah, and then on line 78, yeah, on line 78 through line 80, go ahead and put tab in front of each of those lines.
Okay.
There, there, there. Now,
Okay.
we're very close. I actually saw one more, well, actually a couple more errors, but they're in the exact same error. So, could you scroll up just a little bit?
Yeah.
Okay, so over here, on line 38, do you see how we structured this? We say dollars and then the word dollars. However,
yeah,
in front of the string dollars, we need to have a space so that there's a space between the int
I see.
and then the word dollars. And we're gonna have to do that for each of the other ones too.
Okay, that makes a lot of sense. Okay. Yeah, because I kept on I redid the code like 3 times.
Yeah.
And I still wasn't working, and it was kind of getting exhausting because my hands were hurting.
Yeah, like coding does get like that sometimes.
Yeah. So do I need to do no change too?
No, that should stay as it.
Okay. So
I think this worked now. I feel pretty confident in this. Let's see.
I hope so.
I couldn't see anything else. All right. Let's take a moment and see what this says.
Okay.
Expression initializer before 8. Cin does not have a type. Let me take a screenshot of that real fast.
Okay.
And then go ahead and scroll to the top again. Let's look at the fix and see what the problem is there.
Okay.
Oh, for your int main, you're missing a bracket. You're using the brackets for your int main. So what I need you to do on line 5 is put an open squiggly bracket.
Oh.
Yeah. And go behind it and press backspace so that it lines up. Let's go to the bottom and see if that squiggly bracket has a closing squiggly bracket to accompany it. Yeah, it does. Okay. So that's the issue with line 6. Let's see what
Okay.
line 13 is about.
CN.
Well, actually, try running it again. Maybe that was the only issue.
Okay, so it's like just offshooting it.
Yeah, because when we fix one error, maybe the other ones will go away.
No.
It's saying 9 nickels and 45 pennies. Okay, scroll back to the top.
Yeah.
So there's a problem when we're
Yeah.
okay. So okay, I see it now. So you say, so on line 19 you say user input minus $100. You're actually supposed to say user input equals and then all that.
Oh.
Yeah. So go to line 19.
Oh wait, was this fine?
We actually have to fix lines 19, 22, 25, and 28. So
Okay, so it's supposed.
no, go ahead and change that back to a minus sign. Yeah. That was right, but what we need to do is right before all of that, we have to say user input equals and then all that.
Okay, so like right here?
No, before that too.
Okay.
In the very beginning of, yeah. And then
Okay.
move over a character, like move to the right one.
Okay.
Yeah. Say user input equals that.
Okay.
Yeah.
User input.
There you go.
Okay, so I'll just copy and paste that.
Yeah, copy that and put that on line 22, 25,
Yeah.
and 29.
Okay, I had no idea how I saw it because I was like looking word for word on your code on YouTube.
Yeah.
Okay, that should be it.
Yeah. And the spacing's off, but the spacing doesn't matter that much. Maybe it'll work this time.
Yeah. Okay, 8 out of 10. We're getting closer.
Yeah.
Oh. Hold on. I think I could just change this to C. If this works. Okay, great.
There we go. Excellent work. Good job.
Thank you. Thank you. Have a nice weekend. Thank you so much.
All right. Bye, Miss Valerie Mora.
Bye.
Have a good weekend too.
You too.